Okay, previously we had done the derivative of the natural log, which is 1 over x. So we're just going to the other direction. So it makes sense that the antiderivative of 1 over x, if I integrate this, will lead me to natural log of x. Okay, so let's just work through a couple examples. Don't forget the use substitution idea on some of these problems. So typically, when you see something on the bottom raised to the first power, that's how I know it's going to be your natural log. So this really is the same as this. Right? Any numbers, coefficients we can just pull out. So the antiderivative of 1 over x is just natural log of x. The 2 stays in front, and you put the absolute value bars there saying that you cannot take the log of a negative number. And don't forget your plus c. Okay, now the rest of these problems will have a u substitution idea. So your u will be the entire bottom. So u is 3x squared minus 5. My du is 6x dx. And again, if you need to rewrite it in terms of u, go ahead and do that. So what happens is when you rewrite this, the whole bottom becomes your u. Notice what you have is x dx. So really x dx is really du divided by 6. I'm going to put that 1/6 here. So the antiderivative of 1 over u du is just natural log. So this is 1/6 natural log of u plus c, and then substitute back in your u. Okay, number 3. Again, I see something on the bottom raised to the first. U is 9 minus 2x. Du is negative 2 dx. Again, if you want to rewrite it, you can. So the entire bottom becomes your u. Everything else should be your du. The only thing you can be missing is a number. So I have a du, but I am missing a negative 2, so you need that reciprocal. So this is negative 1/2 natural log of u, which is 9 minus 2x plus c. Okay, now some of these problems, okay, these are going to start getting mixed up with some of the old rules, okay? If you look at this problem, number 4, if you just pick your bottom as your u, du is dx, I've got all this extra stuff on the top I don't know what to do with. Even though this problem has a natural log in there, this is actually a power rule. So your u is ln of x, your du is 1 over x dx. That's why that x is on the bottom. So you always want to be thinking whatever your u is, everything else in the problem should be the derivative. Like if you pick that x as your u, everything else in the problem is not my derivative. So if you rewrite this, this is u to the 1/2. Everything left over is du. I'm not missing anything. This is it. This is just a power rule. You're going to add 1, divide by the power. So even though you have an ln in your problem, it's really the power rule. There's my answer. Okay. Number 5. So this is where your trig derivative info is useful. The derivative of the tangent is secant squared. So if you recognize that, you know the bottom's my u, my top's my du. This is just 1 over u du. I'm not missing anything, which is natural log of u plus c, which would be natural log of tangent of x plus c. Number 6. U is the bottom again. X squared plus 2x. Du is 2x plus 2. Notice this is really x plus 1 times a factor of 2. So all you're really missing is that 2. You do have that x plus 1. So I need a 1/2 ln of x squared plus 2x plus c. Okay. Number 7. This is going to be my u, ln of x. My du is 1 over x dx. So what happens is this becomes u on the bottom. Everything else, notice, is du. It's 1 over x. So this is just 1 over u du. Not missing anything. So this is just natural log of u plus c. What is u though? It's natural log of x. So it's natural log of x plus c. And I'm going to jump down to the last one, number 9. So this one, it's not set up as a fraction, and we do not have an antiderivative for tangent, but I can rewrite this as sine of x over cosine of x. So if I write it like that, notice, oh, my u is the cosine, which is on the bottom. the derivative cosine is negative sine of x, which is in the top. So this is really, I'm missing a negative sign. Your 1 over u du, negative ln of u, which is cosine of x, plus c. And we'll save number 8 for another time.